Hello, students. Mr. Murphy here. If you didn't notice, you probably don't know this. I'm streaming on Twitch while I'm recording these. I don't know why, just because it's there. But anyhow, so lesson 5. We are almost done with exponents. We are on the last rules. So we know the definition of a number raised to a negative exponent. So we've been doing everything with positive numbers. Now we're going to jump into negative numbers. And then again, we are going to simplify and write equivalent expressions for negative exponents. So we've been doing that, and we're going to continue doing that, only now we're going to add negatives. So this is what we know. We have x to the m times x to the n, so two exponents with the same base. If you multiply them, you add the exponents. Related to that, if you are dividing exponents of the same base, you're going to subtract the exponents. If you have an exponent raised to a power, then you multiply the exponents. There's no correlating division one on that. If we are multiplying two numbers raised to a power, then you can split that up and say the first number to that power times the second number to that power. So I've seen it on the homework for some of you guys have been saying, well, you kind of distribute the exponent. And, you know, it's not right, but it is right. It's not mathematically quite precise, but it is kind of what's happening. So I like that. X to the first power is just x. So all of these were powers greater than 1, positive numbers. That means you're multiplying the base that many times. Well, if you don't have the base, if you only have one of the base, it's just there. So you have just the base. If you have the base is 0, it equals 1. And we prove that. That makes sense with these laws. We have to have this. This has to be 1 or it doesn't make sense. Because what if I have x to the 5th divided by x to the 5th, right? Then that would be 1. Because if you divide a number by itself, you get 1. Well, if dividing an exponent with the same base means subtracting the powers, well, x to the 5th divided by x to the 5th would be x to the 5th minus 5, which would be 0, so it has to equal 1. Right? And that's down here. And we say x does not equal 0. Because it's on the bottom here. All right, so what happens when we have negative numbers? So for example, we have 3 to the 5th times 3 to the negative 5th, right? So it should hold true to what we already know. So if we're multiplying exponents of the same base, then we add the numerator, add the powers. So this should be 3 to the 5th minus or plus a negative 5. And we remember that from last year, 3 to the 5th plus a negative 5, well, that cancels each other out. We've got a 0. So 3 to the 5th plus a negative 5 is 3 to the 0, which is 1. So our negative exponents are still working. What does this mean? If 3 to the 5th plus a negative 5 equals 3 to the 0, which equals 1, then 3 to the 5th is the reciprocal of 3 to the 5th. 3 to the negative 5 is the reciprocal of 3 to the 5th. Reciprocal means if I'm multiplying two numbers, and the answer will always be 1. So if I'm multiplying 3 to the 5th times 3 to the negative 5th, and the answer is 1, then 3 to the negative 5th is the reciprocal of 3 to the 5th. We've been used to seeing reciprocals as 1 over the number. So the number, if you want to take a whole number, make it into a fraction, you say whole number over 1. And the reciprocal, we just flip it upside down. So if the whole number is 5, then the fraction for 5 is 5 ones, and the reciprocal of that would be 1/5. This works the same way. So the reciprocal of 3/5 as a fraction, so 3/5 as a 3 to the 5th power, not 3/5, 3 to the 5th power as a fraction is 3 to the 5th power over 1. The reciprocal then would be 1 over 3 to the 5th. And that's 5 minutes, so we're going to stop there and get on with the next one.